Today what I'm going to do is show you how to solve exponential equations. We'll also do logarithmic equations, but we'll save that for the next day. So today we're just going to be focusing right here. So I'm going to show you how to solve some exponential equations with different numbers for the bases, and then you'll try some of those. And then what we'll do is we'll look at some that have a base E. And then you will do your worksheet and your exit ticket and turn those in. So our first objective is just solving exponential equations. Let's look at the mastery ticket. You're going to be able to solve this problem when we're done. And you will also be able to do this error analysis. Notice this one has a base E, and there's some kind of algebraic mistake that is made in the solving of this, and by the end of this lesson you should be able to spot what it is. So let's talk about some steps here. I actually made a mistake, so go ahead and cross out natural. That is not supposed to be in there. There is a way to solve using natural log, but we're not going to do that. So we're going to use logarithms to solve exponential equations. So one of the first things that we're going to do is isolate the base of the exponential term. That's going to be our first goal. So sometimes it's already going to be isolated, but if it's not, we might have to subtract a number or divide or something like that. Okay, and then we're going to actually have to choose a base. So you should probably write that in there. We want to choose a base, then take the logarithm on both sides of the equation. Anything we do to one side, we have to do the other. And then we're going to simplify using the power property. So generally our exponent is our variable, and we want to get that out of the exponent, that way we can solve for it. And then we'll just isolate the variable after we have it out of the exponent. And then sometimes we want to check our answers because we can come up with some extraneous solutions, which means when we solved it, it looks like it's a solution, but when you plug it back into the equation, it actually doesn't work. And that happens for a couple reasons. For one, you're only allowed to take the log on a number that's greater than 0. So we shouldn't get any solutions that would make that not happen. So we do want to substitute and check our answer. So here's our first teacher model. My equation is base 9 with an exponent of 3x minus 1 equals 80. So I want to think about these guiding questions as we're trying to solve this. We need to know if the base is isolated, and if it's not, then we need to isolate the base. So here our base is 9, and see how we also have that minus 1 on that same side? We want to get rid of it, and then our game plan is to take the log of both sides. But the first thing that we want to do first is to get rid of that minus 1. So we can cancel it out by adding 1 to both sides. And simplifying, that's going to give us 9 to the 3x power equals 81. So now the trick is we really need that x out of the exponent. And now we know a few things about logs. And I noticed that my log is 9. So one property that I know is if I do log base 9 on it, I basically just get my exponent. So you can kind of think of this in a couple different ways. So what I'm going to do is I'm going to do log base 9, and anything I do to one side, I need to do it to the other side. So log base 9 to the other side also. So simplifying that, well, you can think about it in a couple ways. Remember that there is that power property that says I can move the exponent down to the front of the log. So I like to think of these logs in terms of that. So let me just rewrite this for a second. So we've got 3x that's going to be multiplying my log base 9 on 9, and that's going to be equal to log base 9 on 81. Well, now we can simplify this a little bit further. So remember, doing the log on something gives you the exponent that you have to raise the base to in order to get that argument number that's right there. So when I'm thinking about this, I mean, I could put it in the calculator, but I can also do it in my head. I still have this 3x here. Well, log base 9 on 9, that's like asking, what exponent do I need to raise 9 to in order to get 9? Well, the answer is 1. So this is like times 1, which I don't even have to write. Okay, and that's equal to, and then I want to do log base 9 on 81. So that's like asking, what power do I have to raise 9 to in order to make it 81? Well, 9 squared is 81. So that's going to give me 2, because that's my exponent, 2. So we actually have a simple equation here. We have 3x equals 2. And we can solve for x. We just need to divide by 3. And that would give us x equals 2 thirds for our answer. Now let's do a quick check. So I'm going to plug this in just to make sure that it works. So I'm going to go 9 exponent 3 times 2 thirds minus 1. And I want to find out what that is. So simplifying that, 2 times 2 thirds is 2. And then 9 squared is 81. 81 minus 1, that's 80. So that checks out and we're good. Let's look at a slightly different problem for that we do. So my suggestion is that you actually pause the video and try it on your own, and if you get stuck or when you finish, go ahead and play the video again and see if you got the correct answer. So let's look at this problem. We want to think about, is the base isolated? I notice that we have a plus 7 over here, and we need to get rid of that. So I'm going to cancel it out with a minus 7, and that's just so that I can isolate the base and then do the log on my base also. So rewriting this, we get 3 to the 2x minus 3, all that stuff is in the power, equals 243. Alright, so our base is isolated, and we want to think about choosing a log. So we want to think about what base should be chosen to do the log to both sides. Well, our base in this equation is 3. So now we're going to use log base 3, and we're going to do it to each side of the equation. So log base 3 to each side of the equation. I'm going to rewrite this using the power property that we learned earlier, which says that we can put the property in front of the log. So I've got 2x minus 3. I'm going to put parentheses around it because that whole thing is multiplying my log. Log base 3 on 3 equals log base 3 on 243. Okay, so now I know that I can simplify these logs. Log base 3 on 3, that's like asking, hey, what power do I need to raise 3 to in order to get 3? Well, that's just a power of 1. So this thing is just 1. And then I want to think about, what power do I need to raise 3 to in order to get 243? So you might need your calculator on that one. It is actually 5. So 3 to the 5th power is 243. So let's rewrite these. Simplifying, we get 2x minus 3 equals 5. So, if you weren't thinking about these things in terms of using the power property, you could be thinking about these in terms of, doing the log with the same base is just going to give you the exponent, because that's what we end up getting down here. So you could simplify that way also. So we just have a couple of things that we need to do in order to isolate the x fully. We need to get rid of that minus 3, so we're going to add 3 to both sides. That's going to give me 2x equals 8, and then we're going to divide by 2 to isolate the x, and that's going to give me x equals 4 for my answer. So after I do that, I want to make sure that I check my answer, because we are going to get into some things later on where we do get extraneous solutions. So here's my check. 3 to the 2 times 4 minus 3 plus 7. I'm checking to see, is that equal to 250? So simplifying, 2 times 4 is 8, so I got 8 minus 3 in the exponent. So that's going to give me 3 to the 5th power plus 7. And then we actually just talked about how 3 to the 5th power is 243. And if I add 7 to that, I get 250. So that does check. So I actually made a mistake in this one. I have a typo. That 3, base 3, is supposed to be a 4. So on your paper, just go ahead and rewrite it. That was a typo that I had made earlier and didn't realize it until after I had copied that paper. So now that you've corrected your problem, I would encourage you to pause the video and then actually to try to finish this problem, and then when you're done, just play the video to check and see if you got the correct answer. Alright, so I want to see, is my base isolated right now? And no, it's not, because we have this 8 right here that is multiplying my base. So we want to undo that with a divide by 8. So we're using that inverse operation. That is going to give me 4 to the negative 2x equals 4. And then I want to see about taking the log. So I need to figure out, well, what base log am I supposed to use? Well, our base log is, or our base is 4, so we want to use base 4. So log base 4 on both sides. And then rewriting this using the power property, I'm going to put 2x in front. Log base 4 on 4 equals log base 4 on 4. And so that's like asking, what power do I need to raise 4 to in order to get 4? And that's 1. So those are both 1. So rewriting this, I get negative 2x equals 1. Then to solve for x, all I have to do is divide by negative 2. So that gives me x equals negative 1/2. So now let's check our answer by plugging it back into our equation and see what we get. So I've got 8 times base 4, and then negative 2 times negative 1, that would make a positive 1. 4 to the 1 power is just 4, and I have 4 times 8, that would give me 32, which is what's on the other side of the equal sign, so that does check out just fine. Next, I suggest that you do the you-do. We're going to be turning those in at the end of the day. Use your guiding questions to help you, especially if you get stuck. And then that last problem is a challenge question. I will count it as extra credit. I have it labeled as challenge because it is error analysis, but I think you guys should all be able to do it, especially after going through these problems in videos.